looking at today, the first and second derivative test combined together. So, a little bit review. We did relative extrema using the first derivative test. We didn't use those exact words, but we used the first derivative to find all the information to tell us where relative extrema happens. And so we learned that relative extrema occur at the critical numbers.
Wait, Mark, was it this?
No, not this. Okay. No. Relative max happens when f prime of x changes from what? Positive to negative. And relative min happens when f prime of x changes from negative to positive. Now there's going to be a second way for us to tell where relative maxes and mins are, and that is called the second derivative test. So if x equals c is a critical number, then f prime, or f of x has a relative max if f double prime of c is negative. Okay, so it's kind of the opposite feeling. F of x has a relative min if f prime at c is positive. Now let's think about why that would make sense. The double prime, the second derivative, talks about the concavity, right? So at that particular critical number, we know we have either a relative max or a relative min, right? And so if the second derivative is negative, it's concave down, right? So wouldn't that be a max?
Yes.
Oh.
And if f double prime is positive, it's concave up, and therefore that would be a min. Okay? Okay, think about it. If the second derivative is negative, that means your graph is concave down. The point on that particular part can only be a maximum then. Okay, it can't be a relative min if it's concave down. If your second derivative is positive, then your graph is concave up, and therefore that particular value you're looking at can only be a relative min. Yeah? Sometimes seeing it visually, when it clicks in your head, it's great. All right, so based off of this information, let's see what we have. If we are given original function g of 2 is equal to negative 3, okay, then we're given g prime at 2 is 0.
So that's critical number.
It's telling us 2 is a critical number. Yes? Okay. Because it's the x when it equals 0. Yep. So that's our critical number. So because it's a critical number, they've then gone on and told us the second derivative at 2 is equal to negative 4. This is pure second derivative test. So because we are given this is a critical number, we then look and say, okay, the second derivative is what kind of number here? Negative, because it's a critical number and the second derivative is negative. What does that point have to be? It has to be a relative max. Okay? So f of x.
Or g of x.
Yep, thank you. G of x. I was looking at the derivative test there. Has a relative max. And we know that relative max has a y value of negative 3 at x equals 2. Now, just like every other thing here, we're going to have to explain why. Why? Because x equals 2 is a critical number.
Why you wouldn't say the double prime, you would just say
We're-
g of 1.
Right, we're still making all conclusions about the original, right?
We just use those.
Mm-hmm. So x equals 2 is a critical number. And g double prime of 2 is negative, less than 0.
What does the critical number thing tell us for this one?
So the second derivative test is based off the fact that it is a critical number.
Yes.
So if the x value you're looking at is not a critical number, then this doesn't apply. So you have to prove that the x value you have is a critical number first, because the critical numbers are where we find maxes and mins, right? So if it's not a critical number, then it's just a spot on the graph that might be concave up or concave down. It doesn't really tell us anything.
On the number line.
Yes, it has to be on the first derivative number line. Then we look at the second derivative to see if it's positive or negative.
Okay.
Okay.
The first second derivative have the same.
So now given a graph, we are told f prime of negative 2 is equal to 0. What does that mean? Okay, that means that this is a critical number. Does f of x have a relative max, a relative min, or neither at negative 2? So interpretation stuff here. This is a critical number. What graph is this? This is the double prime. All right, so we are given f prime of negative 2 is equal to 0, which tells us it's a critical number. That's kind of the requirement to use the second derivative test. Then we look at the second derivative and say, okay, at negative 2, what is my second derivative? Positive, negative? Positive. It's positive, right? So we would say f double prime at negative 2 is greater than 0, right? Therefore, what does that tell us? Okay, so we would say f of x has a relative min at x equals negative 2 because two conditions to this. First, okay, x equals negative 2 is a critical number.
So you have to put that part.
And I'm not even sure. I should probably check on the wording of it. You may have to say because f prime of negative 2 equals 0. But, I mean, that's kind of stated here. So, and f double prime of negative 2 is greater than 0.
So in that case, you only looked at the negative 2 part because it's saying at.
Yes.
We don't look at the whole.
We don't need to look at the whole thing because we just care about it, negative 2. What is the sign of your second derivative?
Oh, we can't figure out the y value.
We can't figure out the y value because we don't have the original.
Would there be a case where it would be neither?
It could, yeah, if it hits right at 0 on the second derivative. Well, because it's not positive or negative then, so which one would you say it is? So it would probably be only if it hits 0. That's got to be a very odd case, though, because that means it's both a critical number and it's a second derivative, like point of inflection, which I don't know how it would be
Or
both.
it's just like of your horizontal.
Yeah, could be something like that. There is no max. Yeah. All right, let's look at the back.
I guess they just have to put it there.
In example 3 here, we have p of x is equal to f of x minus x. Okay, so whatever that is, we're just going to call it that. This is the graph of f prime. Find the x-coordinate of each critical point of P, where x is between -5 and 5, and classify each critical point as the location of a relative min, relative max, or neither. All right.
Well, we know the critical numbers here. This is
Okay, so that's f prime of x. But what about p of x? What's the derivative of p going to be?
F prime of x.
F prime of x minus 1, right?
Oh.
So we say p prime of x is equal to f prime of x minus 1, right? All right, so if that needs to equal 0, okay, let's set that equal to 0 or undefined, right? Okay, right, that's really going to be for us on our graph looking for where f prime of x is equal to what? 1. All right, so let's look at our graph here. Where is f prime of x equal to 1? Let's just make an estimate. 0.5. So x equals 1/2. And 3.5, I'll call that 7 over 2. All right, so those are my critical numbers. Now, using our new test, we know those are critical numbers. Okay, do you think using this, we can make some decisions about the second derivative? Because we can't, like, plug stuff in, do all the different things, because we don't really know what's happening with that. So let's think about the second derivative. Yeah, what would be the second derivative of p of x? F double prime, because what would happen to that 1? It goes to 0, right? So if p double prime is equal to f double prime, let's look at that. how do you know where, based off the first derivative here, your second derivative is going to be negative? Okay, we were given our first derivative.
Where the f of prime x is 2b.
Okay, let's just try to make a number line for ourselves.
Yeah.
Okay? Yep, where it's increasing and decreasing, right? So we're going to call this P double prime, F double prime, both of them, right? Same thing. So how do I know where my second derivative is going to be negative based off the first? Where it's decreasing, right? So this function's decreasing from here to here. Would we agree?
Yes.
So that's from
4,
-4 to -2. It's decreasing. Then what's the next section? From here all the way up, right?
2.
Okay, so from -2 to 2, it is increasing. Yeah?
And from 2 to 5 is 2.
And then 2 on out, it is decreasing. All right. So then let's make some conclusions. Where does 1/2 fall in that number line? Between
And 5, 2.
-2 to 2, right? 1/2 is just the next value between those, right? So because that's a critical number, and because my second derivative is positive, what does that tell me? Okay, so we're going to say x equals 1/2. We're going to say f of, which one are we making conclusions about? P. P of x has a relative what? Min at x equals 1/2 because 1/2 is a critical number. And P double prime of x is greater than 0. Yes?
Why wouldn't you say anything about the first derivative?
Well, the critical number implies that's where the first derivative equals 0, right?
So then we have to write one about
Then we say the same thing about 7/2. So I go back to my number line.
that would go in front of the 2.
Right? 7/2 goes in here. Right? So 7/2, the double prime is negative. So then I would say P of x has a relative max at x equals 7/2 because x equals 7/2 is a critical number and P prime, double prime of x is less than 0. I just stopped writing. Yes. Yep. Because it's the second derivative test, so it's contingent on the second derivative. Yeah? All right, now, 3 brings back, or this last question we're going to do here, brings back what?
dx.
Yep, dy dx. All right, so I would like, and I'm just going to forewarn you, B requires way more space than is right there. So, just for the sake of our time, I'm going to make, for part B, like start work up here, but like take the right-hand side down here and use that too, because you're going to need it. Okay? So right now what I want you to do is do part A. Show that, because you should be able to do that still. And then try to find that. There was one change I wanted to make. Yeah, that's what it is. Don't find that there. Determine, change your directions here, whether, okay, at this point is a positive or negative. That will be more like normal directions. Okay? Because when I go plug it in, I really just care if I'm multiplying it by a positive or a negative, right?
Right.
So once we're here, now we go back. Okay? Let's go a piece at a time. Maybe we don't need as much room as I thought we did, but we saved some.
Back to that.
Yeah.
There,
Mm-hmm. All right, so our dy dx at that point is a positive number. We want to know if our second derivative at that point is a positive or a negative. So let's go find out. Okay? So plugging in from left to right, what I do need to know. I know that negative sine at pi. What is sine at pi? 0. So if I'm going to bother to plug in 1 minus 2 times whatever the y is, nope, whatever number that is, it all goes away. Okay, because 0 sine at pi
Oh, you're
is 0.
Okay.
Yep. So then I move on to the second part, and I say minus. Okay, what's cosine at pi? Negative 1 minus 1 times negative 2 times a positive number. Right? Over, now everyone look at the bottom with me. What is the bottom going to be no matter what you plug in?
Positive.
A positive number. Okay, I'm not even going to bother plugging it in.
Because he's scared.
Right. All right, so now let's finish working out the top here. Negative here times negative 2 makes it positive 2 times what kind of number in there?
Negative.
A negative number over a positive number. What kind of number am I going to get out of this?
Negative.
A negative number. So we determined at that point we have a negative number back out. Yes?
Do you have to like set it in the statement what?
No, we showed our work.
Wait, how do you get positive number from the bottom?
Because when it's squared, no matter what you plug in, it's going to be positive. All right, now let's look at part C. Find all points on the curve where there exists a...
Horizontal.
Okay, where do we get horizontal tangent lines? Okay, so in this case, dy dx is equal to 0. So if dy dx is going to be equal to 0, we set what part equal to 0? The top. So that means
Oh, because
it's a fraction, yep. So if cosine x minus 1 is equal to 0, this means that cosine must equal positive 1. Where does cosine equal positive 1? 0 and 2 pi. But go way back to the beginning. We're on this interval.
So it only be 0.
Only 0. All right? So only 0. Don't need anything else. Now, we'd like to know whether this is a maximum or a minimum. How do we know? Okay, we are going to plug it back in just a second to find the actual value, but let's determine if it's a max or a min first. You do use the second derivative. Okay? Okay? Yeah. He's in tech theater, so he can
On his clothes. Yeah.
move on and come over here. All right. So in order to determine if x equals 0, is that you plug it in. Yep. Which in reality, here's the best way this question would have been written. If that point 0 had been like what you just did in part B, and you already determined whether it was a positive or a negative number. So then you're using part A for the derivative, part B for whether that's a positive or a negative, and then you just answer in part C. But, you know, when we change questions, it makes things less fun. So if I want to determine whether the second derivative is positive or negative, I do need an x and a y, though, right? Mm-hmm. All right, so how do I find a y for that x?
Would you plug it into the first one?
You plug it into the original.
Oh, right.
Yep. So looking at the original, that's 0 plus y equals y squared plus, what's the sign at 0?
Oh,
0.
we're plugging it back in the original.
Yes. So we need to find the original. How do you solve something like this?
Factor?
Factor. Move everything to one side. Y squared minus y. Factor out a y. And get that y equals 0 or 1. All right, so I've got 2 points. I've got the point 0, 0, and I've got the point 0, 1. We want to determine whether each one is a relative max, a relative min, or neither. Okay? So because of that, I need to plug both of those points into my second derivative. So I will do second derivative at the point 0, 0. Well, we've already said sine at 0 is 0. So I don't even worry about that second parentheses there. minus, what's the cosine at 0? 1. Oh, wait, when I do 1 minus 1 here in that first parentheses, what happens to the whole top? The whole thing goes to 0. Okay? So what does that mean about the point 0, 0? Is it a relative max, relative min, or neither? Neither. Why?
Oh, this is what you were just talking about.
Mm-hmm. Neither, because it would be a point of inflection. Yep. Which means it's not a relative max or min is neither because it equals 0. Therefore, because it's never positive or negative, it is neither a relative. I mean, if it was a free response, I'd explain as much as I can. Because that equals 0, that second derivative is neither positive or negative, therefore it's neither a relative min or a max. Okay?
But could we write this down?
Oh, yeah. Then I would also check that at the same other point. This one you'd have to have a calculator to plug in because you're going to end up doing, well, that's a lie. Oh, hang on. If you do that, does it matter? Wouldn't it be the same answer? Because the y changed, but the x doesn't.
Yeah.
So based off the same facts, we're still going to get 0. So it's neither 1. Okay? Because you're still taking the sine at 0 and the cosine at 0, which results in the same answer. Okay? All right.